So my name's Ed Lewis. I work for ICANN, and before I get going on the slides, I'll give you a little bit of background. And listening to Karen's talk earlier made me think of this. I used to work for the U.S. federal government for 10 years, and I left before all of her talk began. And the reason why I left was because her talk began. At the time in the early 90s, the government was running, the U.S. government had pretty much was funding most of the internet back in those days. And I saw, as someone who worked as an engineer and a contract monitor, that the government really wanted to get rid of it. We didn't want to control it, and we being the U.S. government, but we also needed to be there. And that's kind of why it's been this stalemate for the past 20 years, trying to release the control over the name system and all this. So I really vouch for the motives of what's going on there, because it affected my career. I left to go outside when I saw the U.S. government was not going to try to stay in here as the technical leader of the internet. Now, following that, I worked for a DARPA contractor, and the thing I worked on there was a project called DNSSEC, amongst other internet protection systems. And I eventually became stuck with an assignment to run the first workshop of DNSSEC. And that workshop, Liman is smiling already, was held somewhere in a country called Sweden. And that was our first time to Europe when I came back. It was in 1999 that we did this workshop. I know Patrick was there, Liman was there. I don't know if was anybody else at that first workshop? I think I saw one or two people that might have been there. Johan's there? Okay, it was in some town in Sweden. I can't say the name because it's in Swedish, and I don't speak Swedish very well. So, is it Knista? Yeah, I told you I can't say it. DNSSEC has been played with technically in Sweden from 1999. That's when we brought Bind over and played with it. We found 12 holes in the protocol, 12 holes in the code, and since then it's gotten worse. So, with that, I'm going to talk today eventually about rolling the KSK, the root zone KSK, which is kind of going from, we just wrote this piece of code yesterday to now we're trying to formally change the way the entire internet does security. It's kind of a big leap in between then. What I'm going to start with first is a background on DNS and DNSSEC to kind of give you an idea, if you don't already know, what it is I'm talking about. Why is this significant? What's behind all of this? I'll try to go pretty rapidly through that part. As I note, I have more slides than minutes, so I obviously will have to go through quickly. The next part of this, I'll talk about ICANN does. What are the things that are done within the ICANN and IANA functions to manage the KSK? And then finally, the next part will be to look at the validating side of DNSSEC. And this is the side where I think most everybody in this room would be, if you're at all touched by DNSSEC or DNS operations, this is where you will see the impact. And once I get through all that, then I'll talk about rolling the key. So for those who don't like protocols, the DNS is, you ask a question and you get back an answer. The DNS is not a client-server protocol. It has intermediaries, so we really had to invent something else to protect stuff, which is you ask a question, you get back an answer, plus a signature. That signature is kind of like a checksum from the originator saying, here's what you should have gotten from me, or here's a way to check what you have. Now, for that to be useful, you need a key. You have to get a key somewhere that will be part of the process to tell whether or not this is a possibly trustworthy answer or not. And we end up with a diagram kind of like this. This is what cryptography comes down to. I send you a piece of data in blue. I send you a signature I have in green. And the bottom on purple, you get a key. Those three things together go into something which says yes or no. And in cryptography, it either verifies or it doesn't verify. Now, what happens if it's an X? When it's an X, you get trouble tickets. Because what happens in DNS is that if the cryptography doesn't work, the answer is not going to come back to the user. Someone who's sitting at a web browser wants to go somewhere, they look up the name, they get back, it doesn't work. They're going to call up the ISP NOC and say, or the help desk and say, the internet's not working for me, I can't get to where I'm going. Because one of the problems is that we can't tell the difference in DNS whether it was a DNSSEC validation error, or something was wrong, or a cable was cut. There's no way of telling anyone which detail it is. So you end up with errors at the NOC. Comcast has paid the price for this because of DNSSEC mixed configurations, and that was documented a couple times a few years ago. And also why I keep apologizing to the Comcast engineers. So, like I said, this is why this talk matters to the crowd here. I believe, if I'm not mistaken, people here work for ISPs. Yeah, you deal with trouble tickets in some way. You deal with the DNS as a service to your customers. If what I'm talking about today if we have problems with what I'm talking about today, it will come down on your NOCs to deal with the outcome. So we want to avoid that. Now, I should also say that DNSSEC is not just crypto. The crypto check I showed you is just one element of DNSSEC. There's about a dozen checks in there for whether or not an answer is valid or not. Any one of these could go wrong and cause problems, but the crypto is probably the one that's most visible. So at the source, when I go looking for data, when I go back to the very source of the data, there's going to be a list of answers, and I have the blue lines here are the data. That's what we used to always have in DNS. The green lines are the signatures, and on top I have the key, and that's at the source of where I want to go. But the problem is that the DNS is really big, and I don't always want to go to that one source. There's a whole lot of things out there. So to make this protocol work, we had to create, we had to follow the hierarchy of the DNS, and we had to figure out how to make the key that you're going to see that was in this previous slide actually be trustable. An untrustworthy key is not worth anything. As a reminder, DNS is hierarchical. Someone has actually been claiming that DNSSEC is a bad thing because it's a very hierarchical single source system. The problem is it's protecting something that's a single source system, so we were kind of stuck with that design choice. To scale the trust, we invented a couple things called KSKs and ZSKs. Again, I don't really want to go into the protocol too deeply, but we have these different kind of keys. They're called roles. Keys perform certain roles. They're used for this, they're used for that. It's part of the way we chain trust. And also we invented something called a DS record. Again, I don't want to get too far beyond that because I'm getting into the protocol. It helps me link things up. So what I have is this a picture up here. I have the DNS hierarchy, and on the side here in the purple, I have a stack of keys. Now the key that I was using originally was the bottom key in the bottom down here, the NIC SE key ZSK. That's the key I needed to validate the answer I had in the very first slide. The reason why it has any trustworthiness is because it inherits it somehow from this chain of keys all the way up to the top here to the root key KSK. And to kind of cheat ahead, this is the key that I'm going to talk about eventually through the talk. Now for those of you who do know DNS, without DNSSEC, there's actually an analogy in this hierarchy. But I'm going to skip over that. So it's really at the source. Whenever you try to get data from something, you're going to get, this is the answer for something. That's a signature, but also these keys need to be retrieved. And if there's anything below that, I have the DS records below there. So this chain of trust, this is something that's very important to what I'm talking about today, is we have to build this chain of trust. The purple boxes have shown that how this goes down through one leg of the tree, one path through the tree. You imagine there's ones for every single path out there that's DNSSEC signed. But it comes down to this, if someone can trust the root zone's KSK, you can then link to all the other keys that are similarly signed that way down the tree. And to kind of sum up this first part of the talk, which I went through really quickly, this is the key down here that I was talking about originally. I'm going to switch focus to looking at this key up on top, the root zone's key record, KSK key. And that's what that's what we're going to roll out there. And if you can imagine, rolling this is going to be kind of hard because I have nothing above me. All these other ones can be rolled a little bit easier because there's something above them to link down to it. Now, so where do we need to go to? We have to talk about if you want to trust this root key, if you want to have a chance to trust this thing up here, we want to look at the life cycle of the KSK. From the time it's created to the time it's destroyed, how it's used. We want to talk about the risks involved in the key. We have to be able to make sure that that key is something that you all really, really want to put faith in is being used correctly, being used in the right way, and so on. Besides that, the other problem is the distribution of the key. I might have a key, the private and public key for this system, but if you don't get it from me, you may have the wrong key. Someone may give you the false key, and it's not useful. There are two parts to this. First of all, I have to have the key that I have operate in a very secure manner, very proper manner, very reviewable manner, but also to make sure that you can get the key, because you're going to need a copy of it somewhere. So I want to spend time now. I'm going to get more into how ICANN manages the key. Two slides here about the kind of the contract status and the situation we're in. ICANN is performing these functions as the IANA functions operator, which is the contract that was being mentioned in Karen Rose's talk. it comes from NTIA to IANA functions, and we do the work there. As part of what's managing the DNSSEC at the root zone, there are three players. There's ICANN as the KSK manager through IANA. We have NTIA overseeing this, and then we have VeriSign, which is also doing part of this as the ZSK manager. The ZSK and KSK are split between two different bodies in the US. So, we want to, at ICANN, we want to be able to run the KSK in a way that people will actually trust it. So we set out with a couple of goals. These goals are referring to work that's been done maybe 6 years ago. First of all, we want to have the community be involved. The community has to be involved. This is not just about ICANN trying to produce something that someone's going to consume. This is representative of ICANN community's way of wanting to have a secure DNS. So first thing we have 21 roles filled by non-ICANN people, not non-ICANN staff people out there, and I'll explain that more later on. So every time the KSK gets operated upon, there's people that are going to be watching this at every move. The next thing is we use a third-party review, which means we have auditors come in, they watch the system, they make sure that everything that is done with the key follows all of the documented procedures and all the code that's involved is there, that all records, all artifacts of the ceremonies I'm going to mention come up are all properly maintained, that it shows exact use of the key, there's nothing underhanded going on. The next part is in designing this entire system, we wanted to emphasize that no one could, that if there's an incident, it could be detected rather than being prevented. If you've ever set up a security system, you have a couple different ways to approach this. You can try to set up a security system where it prevents anyone from ever getting into the system, which is very expensive and it's very hard, especially in a very distributed manner. Or you can have it where if anyone does get in, you want to make sure you know that they did. And we're optimizing more for the second half of this. I was talking to somebody about preparing these slides, and I said, for example, what this means is that there are certain kinds of security systems out there that if you were to break through them, you tunnel under them, go around them, you could take whatever you want out of it, but then patch it back up so it looks like nothing ever happened. There are other systems where you can get into them a little bit easier, but you can't possibly fix what you tore through. And the second half is what's after that. Not to say that the key is available for someone reaching across the shelf and getting it, but the optimization here function was to make sure that no one could get away with accessing this when we did an audit. We also have multi-party staff operations. That means that within the ICANN staff has a bunch of roles. We are the operator. We have to do the work. But no one person can ever handle the key in isolation. No one has access to the key or the different levels. You have to have multiple people at a certain time. You have to, in other words, if you want to get in there and use our key, you have to convince about 7 of us to do something really bad. And 7 is an approximate number. The disaster recovery plan that they put in place, this was designed a couple of years ago, so we were wondering what happens if we're told there's a natural disaster or some other security disaster and people can't fly in. This is the problem we had in 2001 in the US when we had the terrorist attacks hit New York City. There was no flying across the country for 3 days. We couldn't just fly in new equipment to rebuild the network at the time. We had to come up with another way. So first thing we started out with, we have a secure foundation. And this is just a list of features of the security system out there. We have data centers. We've got 2 of them. And inside the data centers, they have nested levels of security, meaning that there's an entry room, there's a room for the ceremony, then there's a cage which holds other stuff, which including safes. Inside safes, there are more boxes to get through. It takes quite a while to get in and out of this. You have to go through each level with the right number of people to get in and out of that. The computer hardware that's used, it's air-gapped. And frankly, it's getting harder to do that these days because the computer equipment that we're using is now 6 years old, and it's actually able to not be on the wireless. Wireless is being built into everything these days, so we do tech refresh of the system. It's getting a little harder to really be able to gap this from the network. We have only needed features put into the system. We have the laptop that runs this has no internal disk. It has no internal Wi-Fi. It has lots of nothing in it, just a CPU, and it runs everything off a bootable CD or DVD, whatever it is. All the software involved, including that disk, what's on the disk, is all available for public review. We make sure that we're running exactly what's on the website. Everything can be pulled out, and you can review it yourself. Every time we get to use the key, I have a private key there ahead of time. Every time we use the key, it's recorded. We have a recording of every time equipment is used that touches this key. You can go today onto a website that I'll give you a little bit later, and you can watch, if you want to, every minute that this stuff has been used in the last 5 years, just by going from tape to tape. And between tapes, there's ways of saying that nothing's happened in between the tapes. And we also have a published DNSSEC practices statement, which documents our procedures for this. And I was told if I show this slide, you won't throw tomatoes at me, because these are some of the people that helped us build the system, and I understand they have better reputations than I do here. By the way, Jacob is fuzzy in the picture. I didn't have a better one. Okay, so one of the other details about keys I didn't mention before is that each key in DNSSEC is actually two keys. It's a pair. Private, public key pair out there. These are just two keys that work together. One encrypts something, the other one decrypts it, and vice versa. But we always pair them up. So for any particular zone, I have a KSK public, KSK private that work together, and a ZSK public, ZSK private. It's kind of a detail. Now, anytime the private key is put to use, we have a ceremony. We have these key ceremonies 4 times a year. In fact, the next one is going to be on November 12th. It's in about 2 weeks, roughly, from today. 2 weeks from Thursday, anyway. The ceremonies will get people together into a room, and I'll have some pictures of what happens in there coming up. We have people coming in to witness this who are both not just staff of ICANN, but people from outside. We have volunteers who are committed to being part of the process. We also stream video, and I want to kind of advertise that. The video of this event on November 12th will be live streamed around anywhere we can go. We've been trying to now promote the idea that this is it's always been live streamed, but never been promoted that much before. Last time we did a little bit of a announcement of it ahead of time. We at least doubled or tripled our viewership from like 30 to 100. Looking at this to see what happens during the ceremony, so we'd like to have more input to that. We'd like to have the review. The review really is there to gain the assurance in what's going on. Between the ceremonies, all the KSK assets, and I mean the devices and everything else involved, which I'll get into, they're kept in tamper-evident bags, tamper-evident states, basically, in bags. So you see something taken out of a bag at a ceremony, we use it, you watch it on the video, we put it back into a bag, the bag has a number on it, and we cut to the next tape. When that piece of equipment comes back out, it should have the same number in that bag. That's how we try to maintain that nothing's happened in between these video recordings. The ceremony, the reason why the ceremony exists is that it explains why these seals are broken, the seals in the equipment. This is our approach. For those of you who have ever done DNSSEC, I don't know if you've ever had a key ceremony. I worked in a place for the past 10 years where we had a key ceremony also, but for very different reasons. The ceremonies are meant to show why alarms would go off in other cases. We use tripwire in some machines in my other place. Whenever we change keys, tripwire would flag lots of events going on that we didn't want to have going on. But the ceremony said, well, here's why. And ICANN, the ceremony is there to let people know why this key came out of hiding, how it got used, what was the result of that, and everything should be traceable through other sources. Now, the history of the root KSK is that in 2010 it was created. The KSK's public-private key pair was created. Initially installed on June 16th of 2010 into 2 HSMs, and I'll get into that in a second, in Virginia. And that was the first time we used it to start working on the DNSSEC. It signed the root zone ZSKs, which is a protocol detail. About a month later, the key was installed into 2 more HSMs in California, the United States. And so now we've had 4 HSMs hold the keys for many years, and this has been updated since then. And again, if you really want to see what happened, this website down here has all the artifacts from all the ceremonies to date. Currently, I think we've had 22 ceremonies. The 23rd one's coming up. You can find all the documents, all the videos. You can watch all this. If you try to watch them all, I'll warn you, the first one's 8 hours long. But they're not all 8 hours long. They get shorter after a while, usually around 2.5 hours. Although if you understand baseball, it's like watching a baseball game, frankly, 2.5 hours long with like 5 minutes of action. So, and I'm a baseball fan, I like to say it that way. So since then, the Culpeper facility, all of the odd number ceremonies start there in the spring and fall, and again, November 12th will be the next one there. Every 6 months, we alternate the HSM that's in use. We do the same thing in El Segundo. El Segundo is winter and summer. All even numbered ceremonies happen there, even all the testing we do on there. And we just go between the two sites. And this is a montage of pictures from the first ceremonies. So you can see an idea if we have a crowd watching. The crowd usually is about that big in the room. It's not that big. This is the, I guess the same group. So on. So I mentioned HSM a couple times. I'm sure people in this room may know what an HSM are. Some may not care. Some don't know what an HSM is. HSM is it's the key holder. Its job is to hold the private key, not let anyone ever see it in the raw. It can come out being wrapped and encrypted in some way. But also, you tend to give it the data, and it sits back the signature to you. And that's how these things work. Its basic role is protection of the private key. It does also key generation and a bunch of other good functions out there. So with a device like this, the difference between using a key and an HSM, the HSM just doesn't let the staff see the key at all, but still now you just transfer the problem. I don't want to steal the key, I want to steal the HSM if I'm a bad guy. So we want to protect the HSM. We have two kinds of security here for this. We have physical security and what I call ignition security because I made these slides up quickly and I didn't know if there's a more scientific term for it. I have availability protection. If these HSMs get stepped on by elephants, can we come back from that? All four of them get crushed. Yes, because when we created the key, we created shares of the key. We have 7 people around the world who have parts of the key available to them. And if you take them together, they can help rebuild the key in some other way. Access protection, physical access, this is what I was talking about before. The HSMs, when they're not used, are in tamper-evident bags. They're in safes. They're inside a cage or inside a ceremony room, inside a data facility, and so on. There's a bunch of layers to get into them. And in terms of ignition, to turn it on, they require to have at least 3 cards put into them. These 3 cards are held in boxes under keys of other people that don't belong to ICANN. We need 3 of 7 crypto officers, not offices, needed to turn on the HSM. Again, to emphasize this public participation, these are the 21 folks I talked about earlier. These are the 21 folks who don't work for ICANN. In fact, I used to be one of these people before I worked for ICANN. We have 7 recovery key shareholders. We make sure they have the shares around them all the time. We need 5 of 7 to reassemble that. We have 2 sets of the 7 crypto officers, or in other words, it's TCRs sometimes, Trusted Community Representatives. They're non-ICANN staff also. There's 7 of them assigned for the East Coast, 7 for the West Coast. They each have keys to boxes inside a safe, inside a cage, and so on. And they need to attend these ceremonies for us to even start the HSM. Now, one of the things that always goes on as an engineer is you think of what if something bad happens? And what we do in this is every time we do a ceremony, what we're producing are signatures that are going to be used in the next calendar quarter, meaning that we've got roughly 90 days to recover from something going wrong. You start a ceremony, you open up the facility, you get the equipment out, and it doesn't work. It's kind of time to panic at that point. The way that we've done this with redundancy and so on is that if nothing works that day, we try another day. And if nothing works that day, we then can go back to the other place. We have some time to recover for this. We don't have a single point of failure as a result of this, but we may be expensive to recover. So far today, I'm not going to jinx myself. I'm not saying anything. It's important that we keep this in mind because people like to panic about fixing things. We don't have to panic. We don't have to do it right away. It can be done later on because we are signing far enough into the future. Now, in terms of changes to the system over time, each ceremony gets critiqued. We have TCRs who love to give critiques. They love to give opinions, which is great. We've gotten a lot of things changed over time, small nits of things. We've changed some of the minor pieces of the ceremony. When it comes down to what we call the core components of this, the HSMs, they're kind of an important piece. They were given the keys in 2010. There was an assumption that a critical internal battery is going to last about 5 years, which is roughly right about now. So we went out and we bought 4 new HSMs that are all did a little better job in distributing their manufacture date and so on. So we have 4 brand new ones, and currently today we've gotten the old key into the new machines. There was a way to do that. And again, if you want to see us do that, it's actually on the video that we're available for ceremonies 21 and 22. So we've kind of done a tech refresh on the HSMs. The new HSMs, right now we have 4 HSMs in the East and the West Coast. Next time around, we're going to use one of the new HSMs for the first time to do the signatures. On the other hand, the KSK has not changed since 2010. Now, why did I bother to mention that it's not changed? Because there's obviously pressure to change it. And why would you even think of changing this root zone KSK? You see it's the top of the hierarchy. You'll see why later on it's kind of a pain to actually get into this, to changing this. But the fact is that when it comes to this entire system, this entire security is based on us having a secret. ICANN has something that's very secret, the KSK's private key. Only we know that, although it's actually in the HSM, but we can get to the HSM. We can generate the signatures that start off the entire DNSSEC tree from that point. If anyone else in the world knows that secret, they can generate their own, you could call them forged, signatures for these things, and that would disrupt the entire idea of security in this whole system. The hierarchy falls apart. You can't trust from the top down. It's really bad. So we're operating on a secret. The secret's important to everybody. Now, secrets don't last forever. We know that from history. Secrets can be one of these 3 futures. If it's forgotten, that means we kind of walked away from this. We don't care anymore. That's no problem. Secrets could be exposed, meaning that someone sees the key. And that's why we have an HSM. Can't possibly see it, but if you happen to get to it, you might be able to see something. The other one, the one that's scarier to me as an engineer for the longest time was this part. It could be discovered. Someone out there might just happen to guess the key. They sit down there and they write 1s and 0s long enough, and suddenly they know they've got the key because they can generate a signature just like mine. It could happen, and there's no control against that ever happening. Probably this won't happen. It's the way crypto works, it's not likely that someone can just randomly guess this, but it's entirely possible. And when I had the slides reviewed, I had, but what happens when it does? And the reviewer didn't like the word when, but I'll tell you, what happens when someone either discovers it gets exposed, or forgotten? It's going to happen. It's got to happen. Everything goes that way. There are 2 things. There's either preparation or practice, and you just have a way out, like, oh, I got to change the key, let me go somewhere. Or you can just panic. Panic's a lot cheaper. In the beginning, it's cheaper. Yeah, I've been in places where VPs got fired because panic was the fallback plan. Let's see. So that's kind of looking at this from the, I call it supply side. Is how do we produce the KSK? How do we run the KSK? How do we handle this? And why do we think that we're doing a job that's actually trustworthy? But that's just me as an ICANN staffer speaking out to the crowd saying, here's what we do. And I don't think that's very satisfactory. I think what I really want to look at is what happens on the other side of this. As someone who's running a validator, or may run a validator, who runs DNSSEC, or runs a DNS cache that wants to use DNSSEC validation, what do you see here? I want to say it's important here that DNSSEC was designed to protect the validator. What happens on the signing side doesn't really matter in DNSSEC. That's just, I'm just making sure that you are able to do your work. And DNSSEC is really designed to make sure the caches are protected. So it's important for us to look at from the cache side of this. The question here now, who's running that question mark? Who runs this thing? Anyone who's doing DNSSEC validation is running this. They're the ones that need to get the data, they need to get the signature, and they need this key to come in, and they need to trust the key. Who's doing this net today? Large providers are doing this, ISPs are doing this, enterprise institutions do this, and anybody with a computer can do it if they really want to. Anyone can do this. Who's doing who's running recursive services like this? When it comes to DNSSEC, there are a couple of very large providers, and 8888 is one. Google's service is actually doing DNSSEC. ISPs, the one that I'm familiar with in the US is Comcast. I'm sure there are others, they don't roll off my tongue. Many enterprise institutions just do that internally. I don't have a really good example top of my head. And the bottom line, I'm sure there are many people in this room doing it because they like to do it. Admit it, Liman. State of validation. For those of you who don't buy into DNSSEC, because it's kind of a lot of work to do, one of the funny things is it's growing faster than V6. I thought I'd get more of a laugh out. Anyway, that wasn't my personal observation. Somebody, Jeff Houston of APNIC, had measured some of the adoption numbers of this, and he saw 14% of lookups through his testing involve DNSSEC. Now, frankly, that's a number. 14%, I don't even know exactly how to use that number, but it's 2 digits. It's pretty high in our game. But the problem for me, and me as the ICANN engineer trying to do this stuff, is no one has a roster of all those who are making use of this DNSSEC. I don't know who's using DNSSEC. I don't know who is using the trust anchor, because that's what we're going to need to run all of this. And what's needed to do DNSSEC? DNS software, that's easy to get. The root zone KSK public keys available a couple places, or you can also use other keys out there. I'm just assuming it's the root zone. Lots of patient and sufficient clue to do this. Actually, that could be mutually exclusive. You could have clue or patience, or you can have patience and no clue. But again, what bothers me is this piece here. The root zone KSK public key, you need to have that. You, as the validator, needs to have that. I want to change that, but I don't know who you are. I don't have a roster. That's kind of like the nub of all of the problem I'm facing today. Okay, so again, back to the validator side of this thing. How can you get the key? I picked iRoot here because I believe Netnod runs a root server. Is that true? Do you run a root server?
I've heard rumors, yes.
Yes, we've heard that you have a service running a root server. You can actually ask Netnod's very own root server system and say, give me the keys, and you pull, and if you do this with dig, I left the sed off of here because I'm really old. Dig here for the DNS key record, for the dot. That dot's important, there's a space there. And you look for the key with flag 257. If you grab for 257, you probably get the key. That will give you the trust anchor. You can also go to www.ICANN.org/DNSSEC, and there's a page where we have the KSK available in 2 different forms. But if you do this, and you rely on this alone, you're not really protecting yourself. Because how do you know that you got this stuff correctly? How do you know that someone hasn't been redirecting, hijacked the iRoot servers, IP address, routes, or whatever? How do you know that the website you went to actually has the right keys? It's available. This is one way to get it. But I'm not saying you should only get it this way. I really think, as an operator, I would never trust just one source for anything, especially in band. Don't ask the DNS for data about protecting the DNS. It's kind of a bad idea. So one of the recommendations, well, actually, this slide is not a recommendation. And because I don't want to get too far into this topic in this talk. A good strategy for protecting yourself is to mix the sources you get data from. And I get this from talking to some operators. I've surveyed a few operators to say, well, how would you begin to trust what I give you? If I said, I'm from ICANN, and you know that because Narani said I'm from ICANN, and here's the key, it's on my hand, and you want to write it down and go home, make sure you get that key, is that going to help you trust when you see something on the internet? Maybe. But you might want some other ways to go out there. And one of the operators I talked to said he wants to have 3 ways. And again, this is not a recommendation. This is from one interview I had. 3 ways. He wants to get it from someone like me that he knows. He wants to get it offline, off what I say it's going to be. But he also wants to count on maybe the software he downloads has the key, because maybe he trusts Netnod Labs to put into the unbound distribution the correct root key, and so on. No single way of getting the key has to be protected 100%, so long as that all of them agree, and then you begin to have some more faith on this stuff. And again, I have no recommendation here because the work I'd like to do in deciding how to make this recommendation, I have not yet begun to do. So once you have gotten the key, the next step is maintaining it. In security, there's 2 things about, in security is a lot of different things, but initial state of security means, how do I go from being totally untrusted to a trusted state? How do I get there? That's a very hard problem. The next part of security is, how do I stay there? How can I maintain trust once I've had trust established? So once you've gone through getting the key that you trust and you have some experience with, and you say this is the right kind of key, the next step is, what do I do to keep it going? And in the realm of the DNSSEC, we have something called RFC 5011, which is titled Automated Updates of DNSSEC Trust Anchors. This is a protocol which allows us to say, given a trusted key, I'm going to introduce a successor key, and over time you will be able to trust it if you follow the protocol, the process that's described in that RFC. Now, I have RFC 5011 in quotes because it's become jargon. We just call it that, 5011. No one uses the full name anymore. ICANN will follow the process in 5011. That's one of the things that we are committed to do. 5011 more or less says this. It says that if I give you a new trust anchor key and I sign it with the old key for a while, 30 days is actually mentioned in the draft, after 30 days you can assume that it's the new trust anchor. It's an additional trust anchor. The reason is because in 30 days, if ICANN hasn't noticed this or somebody else hasn't noticed that it's a mistake, then it's okay. If anyone complains about it, we can investigate and see did someone else forge the key and add this. If the 30-day buffer allows people review this, it lets the community review this. Does this make sense? Is this really going to be the next key? If I put this out tomorrow and there's a new trust anchor out there, you can call me up and say, is this really going to be there? And I'll say, yeah. Or I'll say, no, I don't know what's going on. Someone else is doing that. That's the key element there is the delay, because we want people to put their eyes on it and really say, do I really want to trust this? As we know, people talk. Once it's been out there for that long, it can be trusted. Now, eventually, I can revoke the old key. But that's just a matter of protocol speak. But the whole idea is that I have this thing called an add hold timer. It's a technical term for it. For doing this. Now, 5011 has a protocol, a way of doing this in the protocol in the DNS. But the spirit of this doesn't have to be you can follow this in spirit through other mechanisms. Now, why? Why would you want to follow the spirit of this if you're not doing it in DNS? And that's because RC 5011 assumes that the validators out there will automatically update themselves autonomously when they see a new trust anchor out there. Now, how many people here run fleet? Wow. I didn't know this one. Okay. How many people know? How many people let their servers just run out and do what they want to do without managing them? No one does anymore. Use Puppet. Use other configuration management. You may want to have that configuration actually take over and follow this. So you might want to follow in spirit, but not the protocol itself. So everything we're going to do is going to try to follow that timer, though. So now rolling the zone key. I got 5 minutes. This should be plenty. Design team. ICANN decided that the best thing to do is have people look at this from outside. We got 7 volunteers selected, and over the year they've been working on a draft. We just finished a public comment period, which in ICANN is the formal way to respond to this stuff. It's over, unfortunately. The design team's going to go back and review the comments they've gotten, and they'll make the final report when it's ready. Now, the impact of this is ICANN does something, and validator operators are going to pay attention, perform the protocol or in spirit or update systems accordingly. If not, there will be trouble tickets galore. Now, I want to also said there pretty quickly, I don't want to make it sound like we're calling the shots. Who's calling the shots here? It's not ICANN's intent to go ahead and do this and force people down a path of badness and trouble tickets galore. But we have some problems. One is that there's very little monitoring available for us to do. ROC 5011 is something we cannot possibly measure. We don't know if you're running a validator whether or not you followed us or not. There's no way for us to tell until we pull the plug and cause trouble tickets. So we want to have a foolproof, fail-safe plan. It's desirable. We're trying to get there. That's what this design team's all about. We want to do this the correct way. But frankly, it's hard. We've tried to come up with a good one, but it's really hard. What will we do? Plans are not final yet. That's an important part of this slide. We have lots of good ideas. We haven't picked the best way out yet. We should do this soon. We will adhere to the 5011 protocol, at least in spirit, protocol in DNS plus in spirit in here. We will strive to publicize the event well in advance. And my personal one here is working in concert with the impacted parties to avoid trouble tickets. That's a very glossy statement. I know there's a lot to do there. There's a lot of things we can measure, lots of work we can do. We're going to have to do that. Now, this is a slide I want to actually start a discussion on, is what's going to help us do this, what's going to help ICANN do the right thing for everybody. That's what it's all about. And the ICANN staff, the function that I'm talking about. What can we do? How can we do this right? The best way is knowing who to inform. We've got to know who to talk to. I need to build a list of all the people I need to know in the room. I've started working on this already. I want to make sure that we can broadcast on mailing lists that we're doing this stuff, but mailing lists get forgotten, and I'm not satisfied with those. Websites I don't trust either. I want to make sure that we know that the right people are able to go lead their parts of the community in the right way. How do operators establish a trust? Like I said, I talked to one guy who gave me these, I want 3 things. What else do people do? If you have to trust a piece of data, what do you do to vet that data? What's your practices? I really want to know what's the best way of doing this. So what can I accommodate? It doesn't have to be one way, but what do I have to put up there? And then finally, knowing how to gauge the readiness to do the role. You know, frankly, rolling the key is easy. We've done that a lot of times. We screwed it up a lot too. I mean, not ICANN, but the entire community. I worked for a place that screwed it up a couple times. We know where mistakes are made. That's not the hard part. The hard part is we got to tell everybody about it. That's the hardest thing here. So when will this happen? This is a favorite question. I don't know yet. It's complicated. I'm taking this, we're preparing for the change. I'm preparing this is going to happen real soon. It's not. But I'm preparing like it's going to happen real soon now, because in the way of doing that, we're beginning to see that some of the tools out there, some of the public source, open source tools, they're not prepared. They may work, but they're not easy to understand, and so on. We're trying to get through the open source community to make sure that we have the usable tools. Operators, what do they want to see? How are they going to be looking at the right time? The worst thing, too, is to say that we're going to do this really, really, really fast and go out for 5 years like that. We're not going to do that either. So I don't know. Don't know what's going to happen, but we're going to make sure that we do it correctly, and we want to minimize the damage that's going to come from it, because there will be damage. So for more information, one thing I do want to highlight is there is a mailing list, DNSSEC announced. I want to make sure that folks at least have someone from your organization on that list. It's been around for a while. It's used. It gets things. But again, if you don't know about the list, you're not on it, you won't see what's said. And also, excuse me, we have this thing called Twitter. And frankly, I'm too old for this stuff, so I don't really know what to say about it. But we have a hashtag, and we have this @thing. For more up-to-date information out there. And I think that was it. So, did I scare anyone? It wasn't hard enough. I should have gotten the jokes out. I should have scared them. You should be scared. Anyone here love trouble tickets? Anyone don't like trouble tickets?
Trust ICANN athletes.
Yeah, well, I got a bucket over here. So,
Is reliable. Speak straight into it.
hello. Hello.
Yeah, so Sweden is one of the biggest DNSSEC deployments in the world. So I think that it's good that you've come here and presented this. What I would like to see would be some guides on how to check the status of your resolver during the time of the transition. So that how can I tell that it is primed and in a correct state, an expected state for this to work when going forward, basically, and that this information is now stored, so when I restart the process, it'll use the new key and so on. Because I think that is the major thing that I would say is not obvious to everybody. How do I check that this will continue working?
Yeah, certainly that's a good comment. One of the things I've been doing is playing with the open source tools and saying, can I use their management tools to say, can I tell what the trust anchors are? And we've been trying to work with Netnod Labs and ISC, amongst others, to say, will you give me a little tool that says, dump them for me so I can see them? That's a start, at least. But then from that, a guide could be written about making sure you have the right trust anchors.
Yeah, so for someone who is not doing this on a daily basis, in 5 minutes, how can they check the typical resolver they might be running? Like I have a Debian box with bind and DNSSEC enabled for resolving on it. How do I check it when this is starting to happen to see, did it do the right thing? I think that would be a very good help for a lot of the people in the community.
Sure.
So this is Mem from Netnod. Do you have any out-of-band distribution of the existing key or the new key? I mean, you could use like the 20 largest newspapers in the world, even if they're getting smaller and smaller. But I mean, there could be ways to publish the new key, and I don't think that was done in 2010.
Well, my mother-in-law has a T-shirt. I'm not kidding. My mother-in-law is from China, and she wears a T-shirt with the current DS record on the T-shirt. No, seriously. No, the these are all ideas that I'm not trying to shoot down, but yeah, these are all good ideas. Right now, I don't know that we have many options. I mean, this is what I want to survey people for. Number one way ICANN can do this is we put things on the website, which is not out of band, or in DNS, which is not out of band, at least in my terms. We can come to events like this and say, here it is, and you can take a look at it. That's the next thing we can do. Newspapers, I remember back in '99 that was thrown out as an idea, and I know in Sweden I believe that was done, where you printed the .se was in a newspaper here. I'm sure that there, that's something that we're going to have to come up with the operators. One of the ones that I've heard is some operators are willing to download software, and if it's embedded there, take it as one source. They consider that to be out of band. One way to do this is to do it in band so many different ways. It's just how many ways do you have to go before you corrupt enough of them to not get the right answer. But I would say that the way the world's going with the internet, it's hard to be out of band of the internet and still have scalable communication. So it's a challenge, but I'm sure we're going to have to figure it out. I really would like to have an out of band way, but it's amazing how hard it is to be out of band with the internet growing the way it is. You guys are doing too good a job.
Okay, well, thanks a lot for that, President. Oh, sorry, one more. Okay, squeeze it in.
Patrick Feldström, working for Netnod, speaking as chair of the Security and Stability Advisory Committee. We released our document number 63, which was sort of recommendations on design of the root key rollover. In the report and plans that is now created by ICANN, we don't really see that it's not clear to us in what you have written that it's actually visible that you have that you have read SAC 63. So unfortunately, on October 5, we felt required to actually publish document number 73, which, among other things, points this out. Do you have have you seen that? Have you read SAC 73? And do you have any comments on, more specifically, the path forward?
73, no, I haven't. I haven't seen 73. As far as 63, you're right, it's not mentioned much in our document. We list it as a previous work, but we didn't address it initially. Internally, we did talk about it. We didn't document what we thought about it. Not that it matters, but you're right, it's not. We didn't address all the SAC 63's points in this document.
Yeah, but because if I'm a little bit formal, it's actually the case that if an advisory committee to ICANN is actually giving recommendations, ICANN board has promised to ensure that these advice is taken into account. That might, of course, be that ICANN is explaining, no, we think SAC is completely wrong, we're doing things differently, but that must at least be said explicitly, and that's basically what we're asking for. But I'm happy to talk with you about separate. I recommend you read SAC 73.
Okay, I'll look at 73. But yeah, we'll address 63 at some point.
Okay, well, thank you very much for that, Ed.